Hello everyone, and welcome to the review for the Q1 test for Algebra 1. So the first up is this inequality, and it says solve and show all your work to receive full credit, express the solution using interval notation when appropriate, and we have to graph it. So remember, when we have absolute value, that means that when we solve it, we're really going to solve two different equations. There is the positive version, and there is the negative version. But when we do the negative version, we have to flip the inequality. So we solve them each one at a time. Hold on, I'm just anyway. So I would add 24 to both sides, and I get 6x is greater than 72. And we're going to divide both sides by 6. And I'll get x is greater than 12. Over here, I will add 24 to both sides, and I'll get 6x is less than 24. Divide both sides by 6, and we'll get x is less than 4. Now, if you see here, this problem originally was absolute value greater than. So we should have known right away we were going to get the turn signals on the graph. And sure enough, we do. We have an open circle at 4 and an open circle at 12. And from 12, we're going up. And from 4, we're going down. So write that in interval notation. That's negative infinity to 4. It's a soft parenthesis because the endpoint is not included. And the union with the set of 12 to infinity. Next problem. So this one shouldn't take us long. Now, if this is possible, we would expect it to be a barbell, but we're going to run into a problem. And I can see the problem already, which is that before we create the two equations, you need to isolate the absolute value. So we need to subtract the 5 from both sides. We'll have the absolute value of 4x is less than negative 4. Now, we should remember that whenever we get a negative on one side of an equation, an absolute value on the other side, we got a problem. Here, if you think about it, there's no way that something that's going to be done as an absolute value could output a number that's going to be less than a negative. So our answer is no solution. And we'll look at this here in a chart in a second. And so our interval is the empty set. All right, so this one is an equation. So first things up, once again, we need to isolate the absolute value first. So first thing I'm going to do is add 4 to both sides. And I'll get 5 times the absolute value of 2r plus 3 equals 5. Then I'm going to divide both sides by 5. And so then I get the absolute value of 2r plus 3 equals 1. Then I create my two equations. Either 2r plus 3 equals 1 or 2r plus 3 equals negative 1. We're going to solve both of those. We get r equals negative 2. And so I would just do on the number line. All right. You would say r equals, oh, that's an awful parenthesis. I can't live with that. There we go. All right, next problem. So here we have absolute value less than, so we should end up with a shape on the graph that looks like this. Absolute value is already isolated, so we can create our two different equations. Either 2x minus 12 is less than 8, and then we also have 2x minus 12 is greater than or equal to negative 8. And we're going to solve both of these. And I'll get 2x is less than or equal to negative 4. Divide both sides by 2, and I'll get x is less than or equal to negative 2. Oh, you know what? I did that wrong. Hold on. It should be adding 12. Let's say that didn't look right. It should be adding 12 because negative 12 plus 12, you have to add the opposite. So then when I divide both sides by 2, I'll get x is less than or equal to 10. That's better. Now over here, I add 12, and I'll get 2x is greater than or equal to 4. Divide both sides by 2, and I'll get x is greater than or equal to 2. Now, if we look at this, this is 2 to 10. And we'll do closed circles because they're less than or equal to, and we're shading between, which means that this could be written as that, and the interval is 2 to 10. I don't know why the smartboard had the delay in the writing there. I apologize. All right, so this is the fundamental thing we were talking about here, which is if we have absolute value less than a number, and this is less than or equal to, then it's going to look like this. And it also is going to look like that. And that's what we just saw in this last problem. It was absolute value less than. And sure enough, we had the barbell. And we had the compound inequality. When absolute value is greater than the number, then we're going to see this one. And an or statement. Now, if you were in my class, we talked about the Jersey Shore. Absolute value is small. He feels bad. He's got to go to the gym and work out. And when he counts his reps, it's an and statement. Absolute value is big. He's ready to go out and cruise for chicks and use his turn signals. And when he uses turn signals, he either goes left or right. This next, let's skip down one. This one here is whenever we get an equal sign, it's going to be an equal sign here, and we're going to end up with just dots, like we've already looked at. So here we have when absolute value is less than c, and it's negative, right? Whenever we have negative, something funky's happening. Less than negative, we've already seen this example, is no solution. So this last one here is basically the same as what was up here in 5 at 6, except for instead of just less than or equal to, it's just less than. And so this will be D and H. All right. So here, the instructions were to graph this, create a table of values, list the domain, the range, and the family function. So there's a couple ways you can do this. You can put it in a calculator and graph it and get tables of values. You could know that it's a square root function. There's a square root function that looks like that. But the minus 2 means that it's been translated down 2 points. Uh-oh. Didn't mean to do that. I apologize. Or you could have picked out some values. 0. Let me do something here real quick. Apologize for the delay. All right, so if I plug in 0, I get negative 2. Because square root of 0 is 0. If I plug in 1, I get negative 1. If I plug in 4, I get 0. So those are some good points. The domain is 0 to infinity, and the range is negative 2 to infinity. And is a square root function. For this one, we already know its absolute value. But we have a couple things going on. We have something being done to it inside the function. So minus 3 will shift it from the origin to the right 3, because stuff inside goes backwards, and the plus 1 will shift it up 1. Lastly, the negative out front will, instead of the v opening up, the v will open down. If we were to plug some values into the calculator, like say 0, 1, 2, 3, 4, we get negative 2, negative 1, 0, 1, 0. The domain is all real numbers. But the range is negative infinity up to 1. All right, over which values of the function is the function increasing? So it's increasing in this range right here. So it's asking for what values of x. So it's increasing from negative 2 to 2. And it's decreasing here and here. So that's negative infinity to negative 2 and 2 to infinity are the x values, where the y values are going down as x is increasing. Okay, for this one, circle all the functions with the same range as f of x equals x squared minus 4. Now, right away, we should know that this one and this one have the same range. Because if you were to graph this function right here, it would look like this going through negative 4. And this function have the same starting point and have also been shifted down 4. This one has been shifted to the right, and this one has been shifted down 5. Now, if you graph this function right here, what you will find is it looks similar to the parent function, but it has been shifted. 2x minus 3. And so if you look at the graph, what you see is you have the same function that you were looking at before, but it has been shifted to the left a little bit, like that. But it has the same range. All right, for these, we got to do the f of g of 4. So, which of the following functions? So to do this, first we're going to evaluate, we're going to do this one in 2 steps. So g of 4 equals 3 times 4 minus 6, which is 12 minus 6, which is 6. So g of 4 is 6. So really, what they're asking for is f of 6, because g of 4 equals 6. And that'll be 6 squared plus 4 times 6, which is 36, plus 24, which is 58. Hopefully, sorry, that should be right. This one is asking for g of f of 2, so I have to find f of negative 2 first. It would be negative 2 squared plus 4 times negative 2, which is 4 minus 8, which is negative 4. So g of negative 4 is 3 times negative 4 minus 6, which is negative 12 minus 6, which is negative 18. So g of f of negative 2 equals negative 18. just going to scroll down here a little bit. So for number 22, this is asking for g of f of x. So it's asking us to create the equation that does both. And so what this would be is we would do the g function, which is 3x minus 6 as the outer function. The inner function, we're actually going to plug x squared plus 4x. And that will give me 3x squared plus 12x minus 6. Now, what we should definitely double check is that if I plug negative 2 into this equation, I should get the same answer out of plugging into this equation as I got here. So we're just going to double check that real quick. 3 times negative 2 squared plus 12 times negative 2 minus 6 gives me negative 18. So sure enough, it did. So for this last one, and a lot of us forgot this, which was this symbol here means find the inverse. Find the inverse. So what we want to do is we want to write down the original equation. So the original equation was y equals 3x minus 6. So to find the inverse, what you want to do is you want to switch x and y. So x, sorry, that got messed up. X equals 3y minus 6. Then we just want to solve for y. So we would add 6 to both sides, and I'd get x plus 6 equals 3y. And now we just divide both sides by 3. And so I would say that the inverse of x is x plus 6 over 3. Remember, the inverse function is the function that takes you there and then brings you back. The inverse should undo the original function. Now, for these, we have to identify the families. So this is a quadratic. So I know it's the parent function is x squared. But we have to look at what's been done to this function. It's been moved to the left 2 units. So f of x equals x plus 2 squared. But then on top of that, instead of opening up, it's opening down, which is why we get the negative out front. Over here, this is a square root function. But square root functions normally open this way. So this has been flipped along the y-axis. So this is f of x equals the square root of negative x. A negative out front flips it vertically, a negative inside flips it horizontally. All right, so this said sketch the inverse of the function, and some people have trouble with this. One of the things we need to remember is that these functions, inverses, are symmetric along the line y equals x. But an easier way to do this is to remember that you switch the x and the y. So if you just pick a few points on the graph, here this is 3, 0, 2, 1, and negative 6, 3. Then the inverse, the x and y are transposed. So 3, negative 6, 1, 2, and 0, 3. And there's our inverse. All right, for these last two, oops, sorry about the bell, is I'll bring up the calculator to do this, is we're going to want to put the data in the calculator. So I don't know why that's so big. So we're going to start by hitting Stat, Edit. And we need to clear out the data that's already in there. So we hit Clear and Enter. Clear and then Enter. And we just put the data in. 2, 3, 4, 5, 8. When we put the corresponding 1.8, 2.7, 4.1, 6, 20.5. Now, normally we would go and we'd turn the stat plot on. Oh, this is not set up correctly. And then we would zoom in on our data and we'd see, oh, sorry, I got an equation in there already. We'd zoom in on our data and we'd see this. And we wouldn't be sure if that was an exponential or a quadratic, and we'd have to look further. Luckily, they tell us it's an exponential curve of best fit. So now all we have to do is calculate that on our, use the calculator to find that. And so we will go to Stat Calc, and we'll use the exponential regression, and we will calculate. Now, what's important here is that in the absence of instructions, you should always go to 3 decimal places. So this will be, I'm sorry, this is going to disappear, but it'll be y equals 0.802 times 1.499 to the x power. And there's our exponential curve of best fit. It's the same process over again for the quadratic. We'll just bring this over here. Stat, edit. You don't have to clear, you can just type over. I'm just typing in the data into our calculator. And then stat. If we wanted to see the data, it looks like this. And then if we want to calculate, we just go to Stat Calc, and we do quadratic regression. And we calculate. And there's our equation. Y equals 2x squared. Oh, I forgot what the numbers were. Bring them back up. There we go. Almost. Minus 10x plus 5. Let's bring it up one more time to double check that. And so there's our quadratic curve of best fit. So that was the review. If you have any questions, bring them to class before the test. Otherwise, good luck. And everybody have a nice time between now and the test.